Hello class, this is the last section of chapter 2. This is going to talk about how can we keep ourselves safe with electricity and electrical safety. First of all, we need to understand that we can become a part of a circuit. This is called a short circuit. This is where the connection that allows current to take the unintended path. Something went wrong in this circuit and the current didn't go where it was supposed to go. Rather than flowing in its normal path, it actually flows through a person or another object. This path often offers less resistance. We can be less resistant than another object, so the current wants to go through us. And this causes that current to be rather high. Those electrons can move quickly through us, and it can be possibly fatal. We could die from these types of accidents. How does this happen? This can happen if you are exposed to wires, or wires become exposed for different reasons. If there's a damaged appliance and the wire becomes exposed, the insulative cover is no longer there, you can touch that wire and become a part of the circuit, and that is not good. When you touch the exposed wire, you actually create a potential difference. There's a lot of potential energy that can be running through you. And then it wants to go to the earth, so it travels through you into the ground. And you are the path of least resistance, so that goes through you. And we'll talk a little bit later about what can that do to your body. Also, you can protect yourself by resisting some of this current. If you are wearing rubber boots or protective shoes, that's going to take some of these electrons, resist that electricity, and your injuries can be less severe. But if you are barefoot or standing in water, you become less resistant. The current can easily pass through you and again hurt you very much. How do we prevent this from happening? One way we have this preventing from happening is having a third prong on our electrical devices. That third prong is round, and it connects the metal shell of the appliance to the ground wire of the building. Again, the goal is to get the electricity from the appliance to the ground and not through you. What is grounding? Grounding is the charges are able to flow directly from the circuit to the ground connection in case of a short circuit. So instead of passing through you or something else, hopefully that electricity will pass directly to the ground. A lightning rod is an example of this. A lightning rod is a metal rod that's mounted on the roof of a building, and it's very tall, and often that's what's going to attract all those electrons from the sky. And when the lightning hits, it's going to hit the lightning rod. The electrons in the lightning are attracted to the rod. The lightning rod is connected to the grounding wire, so those electrons go from the rod all the way to the ground, and that is the path of least resistance. When lightning strikes the rod, the charges flow through the rod into the wire and into the earth, and this protects the building from damage. This is also why it's not safe to stand under a tall conductor, like a big tree, a big wet tree even. Because that's going to be one of the highest points in the area. The lightning could hit it, travel to the ground, and if you are close, those electrons can travel to you and also electrocute you. The best idea is to stay dry and stay low to the ground. There's also a way that we can protect our house from damage, our appliances from damage, and these are fuses and circuit breakers. A fuse, a wire that carries more current than it's designed to, it's going to be very hot. So if we have too much current flowing through our wires, it can get very hot and it can melt that protective layer around the wire. The hot wire can then become exposed and can then catch fire to other flammable materials like insulation that are close to those wires. So we want to prevent this. We want to prevent this overload of current. Therefore, we have something called fuses and circuit breakers to prevent this from happening. What is a fuse? A fuse is a device that contains a thin strip of metal that will melt if too much current is flowing through it. So there's a piece of metal, it gets really, really hot if there's too much current, it melts. When that piece of metal melts, it blows the fuse, is what we call it. It breaks the circuit. It stops the current from flowing through the circuit, and therefore your lights go out and nothing works. This often happens if you plug too many appliances into one circuit. So you have your hair dryer, you have your toaster, you have your iron, you have your lights. All these things are plugged into one circuit. They're creating a lot of current. They're wanting a lot of charge coming through to them. And that can cause an overheating, cause that metal to melt, and then the circuit is broken, and then nothing works. You can replace these, but it's a little bit hard to replace them, or a little bit just annoying to replace them. So many buildings have things called circuit breakers. This is a safety device that uses an electromagnet to shut off the circuit when too much current is flowing through it. So this device detects we have too much current. We're going to blow a fuse if we're not careful. So that it becomes an electromagnet and it stops the current from flowing. And these are really easy to fix. You just go back, unplug your devices, and then switch the circuit breaker back on, and then your electricity will flow again, as long as there is not too much current. And that's why it's a lot easier just to fix that than to go and take the fuse out, buy a new fuse, and put it back in. Lastly, how can this electric shock affect your body? The severity of the electric shock depends on the amount of current, the amount of electrons that are passing through the circuit. About 0.01 amps you wouldn't really notice it if you were shocked with that amount of current. But if you have 0.1 to 0.2 amps of current, it can be very dangerous. And if you have greater than 0.2 amps of current flowing through you, it can cause burns and even stop your heart. So this is really why you want to make sure you are careful with your electrical devices and not being wet or putting electrical devices next to water. Mostly, your body has a couple different factors that that will affect your body's resistance to these electrons. First of all, your body fluids. All of your cells are made up of fluid, and they have a lot of ions, which are positive or negative charged particles. So basically your whole body is a bunch of positive and negative charges inside it. So if you have all those electrons and protons, that electricity is just going to flow right through you. So that actually is against you for resistance. It lowers your resistance. If you have wet or dry skin, that also increases or decreases your resistance. If you have wet skin, you're going to decrease your resistance because that water is going to be flowing through, the electrons will flow through the water and again can electrocute you more strongly. But if you are dry, you'll probably be shocked less and it could have less of an effect on you. So again, this is keep wanting you to keep yourself safe when it comes to electricity. Most of the activities we've been doing have not had that much current flowing through them to where it would actually affect you seriously. But sometimes we have come in contact with larger devices, electrical devices, and we just want to make sure that we're careful so that we do not hurt ourselves with these. So we're going to do a few examples, a few activities with this, and then we will be ready to take a test. So come with questions and make sure you have your notes filled out so that you're ready for the study guide and the test. Have a great afternoon.